Motor failure replacement is a major economic expenditure in industry, so proactively determining motor failure can help alleviate operation costs. Historically, fan motor failure has been determined by methods such as accelerometer and temperature data. However, it can be difficult to distinguish a healthy motor from one that is on the verge of failing until it's too late. Utilizing facilities of Texas A&M University and fan motors for machine learning training supplied by IBM, Team Sono Solutio brings you a revolutionary new product that can predict motor failure using acoustic data. The device is divided into 4 individual subsystems. The hardware, used most importantly for the physical collection of the incoming acoustic data, and also all other necessary peripherals for the device execution. The data collected is then retrieved and processed by the firmware, executing operations such as Fourier transforms and noise cancellation for increased performance. The processed data is then analyzed by the machine learning, which will conclude whether the target fan is healthy or in risk of potential failure. The results from the machine learning are then read and displayed by the front end for the operator of the device to see. For the hardware, a custom PCB was designed in order to read the acoustic data and provide a clean signal to the rest of the system. Within the device, the PCB is located with the microphone exposed to the exterior of the case for acoustic signal retrieval. This data is then processed by the firmware program running on the Arduino, which then executes the initial signal processing. The finished data is then read through the blue serial port and compared to the machine learning model, which then the results are displayed on the device's screen. In order to make the device portable, a battery power supply is used to provide electricity to all of the components. Directly controlling the hardware is the firmware, utilizing Arduino software and Python scripts. On the device's exterior, a power button is located just right of the screen. Once pressed, the device will then follow a predefined boot sequence to run all of the custom software. The machine learning fits into the data flow pipeline by retrieving the stored data in the memory of the device. Normal operation of the device is comprised of 2 simple operations: a calibration mode, using the atmospheric noise near the fan, then a recording mode for actually recording the target fan. Once a filter has been created, 3 readings will be taken and averaged to reduce any aperiodic noise from the environment. And once completed, the filter will be applied and the machine learning will determine the status of the target. Throughout the course of its development, the machine learning continued to improve and now has over 95% accuracy against the training model. The microphone protrudes from the outside of the device, opposite from the screen, so that the screen will be visible to the operator. This is a demonstration of a typical use of the device, which in this case determines that there's a problem with the motor being tested. SonoSolutio has proven that acoustic data can be used to determine with great accuracy whether or not a server fan motor is on the verge of failure or not. The custom machine learning model used was built to be extensible and therefore will work with other types of motors as well, provided enough data is given to train the machine learning model. From all of us here at SonoSolutio, thanks and gig 'em.